Hello Dave, what can I do for you today?
Did you find out what causes the yield issue?
I found two production tools which might be causing the yield issue. They are highlighted in red.
Did you look at the yield from the perspective of a test bin?
Yes. I am showing you a histogram based on the yield loss from the top 10 test bins. As you can see, test bin 44 has the largest yield loss.
Please summarize your findings into a PowerPoint presentation.
I have compiled a PowerPoint presentation and saved it under the working directory. Please feel free to take a look.
Well, there are two fundamental key points I'd like to emphasize. In the previous IEA systems, the analytic workflow was predetermined and it was built in the IEA. Since 2022, we split the workflow into two parts. The workflow support layer, which is basically an API layer that hosts all the backend machine learning methods and models. And the other part is the analytic workflow itself, but this time it is dynamically determined based on user inputs. Another key point is that IEA 2018 is a traditional rule-based design where domain knowledge is coded as rules in the scripts. In contrast, IEA-Plot uses a technology called knowledge graph to explicitly represent the domain knowledge. Because of this, IEA-Plot facilitates integration with a large language model like ChatGPT. In the field of AI, knowledge graph is a standard approach to represent knowledge required by an AI system. The implementation of IEA-Plot is the first time where knowledge graph is used to represent knowledge involved in the data analytic application. We all understand that domain-specific machine learning requires domain knowledge. In the past, this domain knowledge exists implicitly in a workflow. Now in IEA-Plot, this knowledge is represented explicitly with the knowledge graph. Actually, every machine learning tool or model assumes a particular application context. The problem is when someone takes a tool or model and apply it, the tool or model does not tell the user what is the proper way to apply, nor does it tell the user how meaningful the output is. Our AI software has the intelligence to know for each machine learning tool or model what is the proper context to apply. In other words, IEA-Plot not only provides the machine learning tool or models, but it also has the background knowledge for how to use them in the proper context. While the existing common practice for applying machine learning in test data analytics usually requires some data infrastructure system in the backend, and the dashboard kind of display usually built as a web interface in the front end. Whenever a new machine learning method or model is added into the system, it is simply connected with the backend by taking some data as inputs and generating some plots to be displayed in the dashboard. To follow IEA-Plot, we first need to build an API layer on top of the data infrastructure to support the existing methods or models. Then the key is to develop a knowledge graph for controlling the applications of those methods or models. The knowledge graph in our paper is designed for waiver pattern analytics. Company needs to develop and maintain the specific knowledge graph for their use cases. Sure, I have a few examples of using the IEA-Plot. Okay, so I'm gonna first go to our IEA web interface. And this is how the IEA dashboard looks like. On the bottom left, we can type in our queries and the results will be shown on the right. So let's say I want to investigate the wafer probe data for certain products, and I want to start by seeing the yield loss in the time period. So I'm gonna type in, show me the yield loss in the wafer probe for products ABC, and hit enter. So IEA processed the query on the fly, grabbing the data as specified and rendering a scatter plot like this. I can zoom in. I can also zoom back to see the data. Now I want to see the wafer map patterns in the data I just selected. So I'm gonna say, please list all the patterns seen in this data set. Actually, I just had a typo, but it's okay because our natural language processor will figure out the meaning. Okay, so I listed 3 types of patterns: arc, donut, and center. So let's say I want to take a closer look at the arc patterns. I'm gonna ask how many different arc patterns do we have? Now IEA shows 3 options of the arc patterns: the clock direction, that is where an arc is located on the wafer edge, the length, and the arc thickness. So let's see all of the 11 o'clock arcs. So I'm typing in, let's focus on the wafer map patterns at 11 o'clock direction. So we have these many arcs that all satisfy the 11 o'clock description, and there are actually 3 groups, and the ordering here is based on how obvious the pattern is. And please refer to our paper for more detail on this grouping. Now I'm wondering if there's a correlation between these patterns and some e-test values. So I'm gonna ask IEA to please correlate this pattern to e-tests. And this query takes a while to compute. So now IEA shows the scatter plot. The arc patterns highlighted in red are all concentrated in the top right corner among all the other wafers in this dataset. So this indicates a trend of correlation. And we also have a history bar to record all the steps we've done so far, and we keep the result from the previous query on the far right window here for the user reference.